Hello friends and welcome at my channel. Today let's do one more curve sketching. I would conclude it with f of x being equal to x to the power of 4. Then maybe minus 5x squared plus 6. Let's do all the 7 steps we've been previously doing. And so let's start from the very beginning. What is the domain? The domain is everything we're allowed to put in, so every real number. Pretty easy here. With polynomial functions we have no big issues. Number 2 is maybe symmetry. It doesn't matter actually what is the order of doing these points. So number 2 is symmetry. Do we have any kind of symmetry? Yes, we do. We have symmetry considering the y-axis. Why is that the case? Well, if you consider f of minus x, that would be minus x to the power of 4 minus 5 minus x squared plus 6, and then we have x to the power of 4 minus 5x squared plus 6, which is exactly the same what we have in f of x. So symmetry considering the y-axis, check. Number 3, what is happening if x is running towards infinity? So limit x towards plus infinity. Well, you see, this is a function of the 4th degree. So if x is increasing, x to the power of 4 is increasing as well, and it's getting huge and still positive. So we have a positive value, infinite value. And if x is running towards minus infinity, well, because of the 4th power, we're getting plus infinity again. So simple as that. Number 4, 0 points. X to the power of 4 minus 5x squared plus 6. Put it equal to 0. So what's happening here? Well, we substituted. I can link you to my German YouTube video where I explain how it's done, but I think even if you haven't seen it, it's no problem, no big deal here, because we just say, well, x squared is equal to z. That's why x to the power of 4 is equal to z squared, and that's why we get z squared minus 5z plus 6 equal to 0. And for this we can use, maybe you call it ABC formula, in Germany we call it PQ formula. So this is z12 equal to 2.5 plus minus square root out of 2.5 squared minus 6. Now you easily see z12 equals to 2.5. 6.25 minus 6 is 0.25. We take a square root, so it's a half. So square root of a quarter out of a quarter is a half, and we're here. So z1 is equal to 2 and z2 is equal to 3. But we didn't want to compute z, we wanted to compute x. So we have x squared equals to 2 and x squared equals to 3. x12 equals to plus minus square root of 2, and x34 equals to plus minus square root out of 3. If you do the graph sketching, sometimes it's useful to write it like maybe n1 with minus square root of 2, 0, and 2 with square root of 2, 0, and 3 with minus square root of 3, 0, and n4 with square root of 3 and 0. Alright, that's number 4. Number 5 is derivative. So once again, x to the power of 4 minus 5x squared plus 6. What is f prime? F prime would be 4x cubed minus 10x. Let's put it equal to 0. Let's take x out. We got 4x squared minus 10 equals to 0. So x1 is 0. We put this one equal to 0 as well. We also divided by 2, so we got 2x squared equals to 5. We divided by 2 again. X squared equals to 2.5. So x2 is equal to minus square root out of 2.5. Don't forget we are symmetric. So I only compute one. I think it will be min, if I'm not mistaken. And it must be also min on the other side. We will see. So these are my candidates. Now second derivative would be 12x squared minus 10. Well, if we put 0, you see it's minus 10. It's less than 0, so it's a max. And if we put square root out of 2.5, that would be, what was that? I don't remember. Sorry. This is 12. Okay, 12x squared. So we have 12 times square root out of 2.5 squared minus 10. So squaring is moving away the square root, which is 2.5 times 12. It's 30, minus 10 is 20. So it's positive. That means after that we're going up, so it's a min. And we have one more minute minus square root out of 2.5 because of the symmetry. So max at 0, that means 0, 6, and min 1 at minus square root out of 2.5. Let's compute it together. I don't care, that must be the same value, so I'll put 2.5. I have 2.5 to the power of 4 minus 5 square root, sorry, times square root out of 2.5 squared, and then plus 6. So what do we have? Square root out of 2.5. We square it once, we're going to get 2.5. We square it twice, we're going to get 6.25. Once again, we square it here only once, so it's 2.5 itself minus 12.5 plus 6. So we are at minus 0.25. Minus 0.25 here. And min 2 is at plus the square root out of 2.5. And again, minus 0.25. Alright, points of inflection. What do we have there? So second derivative was, let me write it down maybe, x to the power of 4 minus 5x squared plus 6. First derivative, 4x cubed minus 10x. Second derivative, 12x squared minus 10. Let's put it equal to 0. 12x squared equals to 10. We divide it by 12. X squared equals to 5 divided by 6. We take a square root. X1 is minus square root out of 5 divided by 6. X2 is square root out of 5 divided by 6. And now it's about the third derivative. It's 24x. And once again we put 20. We put square root out of 5 divided by 6. It's 24 times the square root out of 5 divided by 6. It's not 0, so it is a point of inflection. And in order to compute the y values for these two cases, so obviously because of the symmetry is the same, we just put square root out of 5, 6 into our function. So what is f of the square root of 5 divided by 6? This is the square root to the power of 4 minus square root squared plus 6. I forgot 5 here. Alright, so once again, we square it once, we're going to get on a fraction 5 divided by 6. We square it twice, we're going to get 25 divided by 36 minus 25 divided by 6. I multiply times 6 divided by 6. And I have 6 more as a whole number. Should I bring it to the same denominator? Yes, I should. 6 times 36 is 216. So what do we have? We have 25 minus 150 plus 216 divided by 36. Alright. That gives us 66 plus 25 more. 91, right? If I'm wrong, I'm sorry, but I should be right. I think so. It's improper fraction. We're going to write it as a mixed number, which is twice 36 fits twice into 91. It's going to be 72, and we have 19 more, so almost 2.5. All right, so points of inflections. The first one is at square root out of 5 divided by 6 and 2, 19 divided by 36, and point of inflection 2 is basically the same with the x value with the minus. Now we have everything we need. Let's plot the graph. I start with the 0 points. Minus square root of 3, minus square root of 2, square root of 2, square root of 3. We come from the top. Don't forget about the limits. We have the mean right here. We have the max at 6. It's going to be the mean again. This is sketching, so I'm not that precise maybe. And we got 2 points of inflection. So where should they be? Well, you see it's square root out of 5 divided by 6. Square root of 2 is approximately 1.4. Square root of 5/6 would be, well, you see, it's around 0.9, I think, something. So we're close to 1, but we're more on the way to the origin. So it's somewhere here, somewhere there, and so these are 2 points of inflection. So what's really happening there, you see, we're coming from the plus infinity, from plus infinity going down here, through the first 0 point, through the second, and then we're changing our curvature, well, not that much, something like that. Oh, that's not a nice graph, but I'm doing my best. Well, I do it once again, maybe, sorry. Actually, this point should help me, but they're kind of bothering me more than they're helping me. Well, I'm not precise, but I'm just expecting them to be somewhere there. Let's see again. Alright, so I think it should be more here, somewhere. Well, if you have a ruler at home, do it precisely. I'm doing my best. Sorry, I missed them. But this is the idea. Alright, you got it? So, we've been discussing yesterday the function of third degree. Now it's the fourth degree. I think we're done with polynomial functions. And I'll do some more videos about the mean value theorem, and we're going to generalize it, and then we'll move to the rule of L'Hopital, and then I'll show you guys a few more examples. Thanks for watching. See you in the next video. Bye bye.